Hello, today we are solving one-step equations. We will do that by using inverse operation to isolate the variable and solve for the value of the unknown variable.
What are you doing? Go clean your room or something. This is my video. Goodness gracious. As she was saying, today we are in fact solving one-step equations using inverse operations. So let's get started. We know that when we see an equation like this, x plus 6 equals 9, that this is what it looks like. We have an x, we have 6, and then we have 9 on the other side. We also know that if we want to find out what x is, we're going to take away the 6 here, which will look like this, and then take away the 6 there, which looks like that. We're left with nothing but x here, and we're left with 3 over here. So x equals 3. Okay, so that's how we solve for unknown numbers, also known as variables, right? The first thing we do is we find where the variable is, and then we do the inverse operation. This was a plus 6. The inverse operation to get rid of it would be minus 6. So I keep saying inverse operation. What exactly is the inverse operation? It is, excuse me, the operation that reverses the effect of another operation. Or another way to think of it is just what's the opposite. Okay, so these are the inverse operations you need to memorize. The opposite or the inverse of addition is subtraction. And the inverse or opposite of subtraction is addition. If we're talking about multiplying, how do we undo multiplication? Well, we divide. How do we undo division? We multiply. So we reverse the effect. So, fun story. My husband deals with wildlife a lot that gets in trouble in urban areas or like where people live, right? So he'll often have to tranquilize an animal, take it up in the mountains, and then reverse the tranquilizing. So he does the exact opposite. Whatever put it to sleep, he gives it the opposite drugs to wake it up. And that's kind of what we're doing with these algebraic equations, is we're going to do the exact opposite. So in my example right here, when I subtracted the 6, that undid the plus 6, so then there was no 6 at all. All that was left was an x. Okay, so that's what we got to be thinking today. So the first thing we do is we find the variable. The variable was right here. There was a plus 6. So in order to get the variable alone, we need to get rid of that plus 6, that positive 6. How do we get rid of a positive 6? We subtract it. So that's the first thing you do. And then the second step is what I have down here. It's like the little balance, right? And then to keep things equal, if we subtract 6 on one side, we need to make sure that we do the exact same thing on the other side. So the first step is to find the inverse operation to get the variable alone. The second step is to do the same thing on the other side so that they can stay perfectly balanced. Okay, so here is my example that I'm going to show you. If we have x minus 7 equals 4, first step I'm going to do is find the x, which is right here. We want to get that x by itself, so we can just have x equals down there. Okay, it's not currently by itself because there is a minus 7 or a negative 7. So now we got to think, if we have a minus, what's the inverse or the opposite of minus? It is plus. So I'm going to come over here and I am going to plus 7. Now if I'm in debt $7, my account says negative 7, and I add $7 to that account, that puts me at 0, right? If I owe my mom $7 and then I pay her $7, I now am at 0. And that is why if we have a minus 7 or a negative number, that if we add that same amount, we'll get down to 0. And we'll be left with just the x right here. Okay, so that was step 1. We got the x by itself. Step 2 is we need to make sure that since we might plus 7 over here, we need to plus 7 as well on the other side of the equal sign. So when we add 7, we get 11. And then to check it, if I'm thinking that x equals 11, I can come up here and I can check and go 11 minus 7. Does that equal 4? Yeah, it does. So x indeed does equal 11. I checked it. That's exactly how it is. Okay, so let's do this one together. If I have 12 equals x plus 6, the first thing I'm looking for is where's that x? I want to get that x by itself. I found it. It's not by itself because there is a plus 6 here. I need to get rid of that plus 6. Well, because it's a plus, that means the opposite of that is a minus. So I'm going to minus 6. And what is 6 minus 6? It just puts me at 0, right? So now that side of the equation only has x. Okay, so part 2, if I'm going to subtract 6 from this side of the equation, then I need to subtract 6 from the other side of the equation. And that gives me x. So 6 equals x. Here's my check. Is it true that, I'm going to replace the 6 with that. Is it true that 6 plus 6 equals 12? Yes, it's true. So x indeed does equal 6. Okay, let's have you try some now. All right, where's the variable? Where's the number we want to get by itself? There's our variable. We want to get it down to f equals. Now, it's currently not that way because there's a 35 in front of it. Now, what is the opposite of 35? Well, it doesn't say if we're adding or subtracting there, does it? But we do know that every positive number has like an invisible positive sign in front of it. We're just really lazy and we don't put the positive sign in front of all of our numbers. Okay, but that is a positive 35, right? So how do we get rid of a positive 35? Well, we subtract it. And that leaves us with now just f. Oh, I forgot something. This is what I like to do. Once I have done the inverse, I like to cross it out like this so that I know, boom, it's gone. I reversed it. It's out of the picture, okay? And so now, if I minus 35 on this side of the equation, better make sure I minus 35 on this side of the equation. And when I do that, I get 690. That one was a little harder, so I'm really going to make sure that I check that, okay? So here's my check. 35 plus 690. Does that equal 725? 35 plus 6. Oops, I better make sure that I line up my decimals. 690. And I get 9, 10, 11, 12, 725. Yep, and that's what I needed to get to. Okay, so I checked it. I'm good. F, the unknown value, is 690. All right, one more for you to try on your own. Here's our variable. Here's why we can't say that our variable is by itself. What's the opposite of minus 4? Well, that's going to be a plus 4. It's going to give me 0, huh? So I just cross it out. That leaves me with m. If I'm going to add 4 over here, then I better make sure I add 4 on the other side. I'm going to add that up, and I'm going to get 46. Is it true that 46 minus 4 is 42? Yes, it is. So I know that m equals 42. All right, that is how you solve one-step equations. You get the variable by itself by using inverse operations, and then you make sure you do the same thing to the other side. Okay, so here's one for you to do on your own. What do you get? I got 29 equals b. Is that what you got? You did it correctly. Now, here's the last one for you to try. how many of these, select the equations that have the solution n equals 23. Mark all that apply. So if you want some extra practice, then you're going to solve each of these like so. N equals 23, so that one worked. Let's do a different color for this one. N minus 4 equals 19. That's a minus 4, so I'm going to add 4. And I have n equals 23. That one's also n equals 23. Let's try this one. 25 equals n minus 2. So here's the n. This is a minus 2. The opposite of minus 2 is positive 2 or plus 2. And I get 27 equals n. So not that one. And our last one is 12 equals n minus 11. Let's add 11 to both sides. That'll leave us with 23 equals n. So 3 of them were correct. The other one was not. That is solving one-step equations. See you later. Hopefully Maya has her room cleaned by now. Doubt it.